Kelly. We can do that. No, that's not that. Yeah. Okay, hi everyone. Finally got the projector going. Welcome to week 5. Just for those of you who may have missed the email that went out last week, the schemas for assignment 1 are now available online on Moodle. So there's 3 of them. There's 3 different systems that are used by the organisation, Artworks. So they've got an accounting system, they've got a works register, that is a register of all the artworks and whether they've been sold and whether they've been exhibited and so on, and a donor marketing database. Now, you may or may not need all of the data that's stored in those databases, but your job, of course, is to work out what the decision requirements are of the users and design a data warehouse accordingly. So the text is up there. If you weren't here last week and didn't pick up a copy of the assignment specification, that's the first link. Then the three schemas, And I've also put up the marking guide that the tutors will actually use to, including myself, to actually assess your assignment. So you'll actually get a copy of one of those marking guides back with your assignment, showing how the grade was calculated. So for those of you who've done 9003 with me before, you'll be fairly familiar with that kind of marking guide. Does anyone want me to quickly go through those schemas in the marking guide before we jump into the lecture, or are you happy to move on? Okay, let's move on. Okay. So, today's lecture is about a topic that I'm actually not a very strong believer in. Well, that's perhaps putting things the wrong way. I'm not a marketing person at all. I don't have a marketing background, and I tend to believe, some marketing people aside, that a lot of marketing people are of the devil. So I'm not a big fan of the topic, just because I think so often this technology is used for, well, evil's the wrong word, but I think it detracts from the enjoyment of life for some of us. But anyway, it is an important topic that we need to cover. In fact, it was so important that we actually created a unit for it as part of the business intelligence stream about 10 years ago. We had a staff member who was an expert in the area. She's moved on now, so we actually don't teach it anymore. We do have a CRM and data mining unit, but that's quite different in style to the CRM unit that we used to have. So you'll hear me, sorry, for those of you not familiar with the term CRM, Customer Relationship Management, you'll hear me use that term right throughout the lecture. But it is a very common application for data warehousing. And in fact, a lot of the data warehouses in organisations are initiated by two different departments. One, on the one hand, commonly it's the finance department, so the accounting group want to be able to analyse their data in a sort of multi-dimensional kind of way. But the other common group that pushes for data warehousing in organisations is, in fact, the marketing group. So data warehouses are very often used for marketing. In fact, if we go back and look at the history of data warehousing, it's actually marketing organisations that specialise in third-party data, customer data, organisations that actually sell customer data to other organisations for marketing purposes, doing analysis of demographics, market analysis and things like that, that we actually saw the first data warehouses being put together. And in fact, the very early dimensional models that were used in industry tended to be marketing models, even though they didn't really realise they invented a new modelling technique. They didn't call it dimensional modelling, they just called it market analysis. But they really did just look very similar to the kind of modelling that we do within data warehousing. So there's a long, rich tradition of using data warehouses for for understanding customer data better in organisations. So whilst we don't have an entire unit devoted to the topic anymore, it is worth having at least one lecture in data warehousing on the topic, because modelling customer data in a data warehouse environment poses a design challenge beyond just the traditionals, well, say traditional, beyond just the dimensional modelling style of analysis that we've done over the last couple of weeks. So this is going to introduce first of all, what customer relationship management is, but also yet another modelling approach. It's kind of a hybrid approach between ER modelling and dimensional modelling, but it's how you can tackle some of the design issues around customer-based data. It turns out that it's more tricky than it sounds. So we'll first spend probably the first half of the lecture, talking about CRM, what it is, why it's important, and then we'll focus on the modelling side of things in the second half, with the particular emphasis on what's known as Todman's general conceptual model. And we'll also look at a little bit about how Kimball tackles the problem. Okay, so a quick background about CRM. So CRM, as I said, is driven typically by the marketing department in an organisation. So marketers want to be able to know or understand the customer base better, so that they can craft their marketing messages more accurately, and thereby hopefully get a better response rate to marketing campaigns. Now, marketing campaigns are notorious for having very low response rates, in the order of a fraction of a percent in terms of actual success conversion from a potential customer seeing a marketing message being turned into a potential customer. But there is a wide variability in that. A successful campaign will craft a message that is tailored to the particular characteristics of the audience that that are being trying to be reached, and the more tailored that message is, the higher the likelihood is that the customer will actually respond. If a customer feels like they're being manipulated or advertised to, they're perhaps less likely to respond than if they feel that they're engaged in a genuine conversation with real people who actually understand what their actual needs are. So CRM is largely about managing the relationship between an organisation and a customer to better understand who the customers are, what their characteristics are, but I guess most importantly, what their actual needs are, so that services and products can be crafted to better meet those needs and requirements. Now, of course, the ultimate aim of all of that is to sell more product, sell more services, and be more profitable. So try to win over more customers, grow the customer base, retain customers so that they don't churn to a competitor organisation, and convert low-profit customers into high-profit, high-value customers. That's kind of ultimately the aim of CRM. In fact, I really should get Felix to give this lecture, because Felix has got a marketing background. He knows all of this stuff. So if I misstep, please correct me. And if you've got any interesting anecdotes, feel free to chip in.
Create value.
Creating value, yeah. Which is an interesting concept, you know. Yeah.
For the customer, for the company.
Exactly right. It's a shared value experience. We too can be e-business winners. Okay. So CRM is a strategy that governs the relationship between a customer and an organisation, as I said before. But a large part of it is about trying to understand potential customers and acquire them, and retain profitable customers. Note that there's a descriptor there around customer. It's a profitable customers. Not all customers are necessarily profitable or highly profitable. One of the perhaps most evil aspects of CRM is that often it's used to identify low profit customers. I was obviously showing my biases here, and then encouraging those customers to leave the organisation, to go to perhaps a competitor, and the competitor can take the cost of having the low profit customer. So CRM is about, as Felix said, creating value for the organisation, value for the customer. As Tottenham puts it, it's a strategy for optimising the lifetime value of a customer, and that's actually can be quite a difficult thing to calculate and understand, because you're talking about potential future purchasing decisions that the customer is going to make. We're talking about potential goodwill and reputation that customers help create for the organisation, particularly in the environment, the commercial environment we find today, with everyone's just about is on the internet. You can go and read reviews of people. People can complain quite vociferously. On the other hand, if you encourage good customer relationships, you can actually have customers doing your marketing work for you, creating strong word of mouth, creating a strong reputation. No, that's actually the last classes. You can read it if you want. It's about social policy. Which, now that I think about what I've just been talking about, it kind of is social policy. So, look, CRM is not anything new. It's something which any organisation that's dealt with customers has had to do right since organisations were first formed. Any organisation that's got customers has a relationship with its customers and has to manage that relationship. Some organisations do it better than others. However, a good customer, or an effective strategy for managing a customer relationship, is dependent upon being informed about who the customers are and what they want, what they need, and so on. And if you don't have data to support that, then you're making uninformed decisions, which can have drastic consequences for the relationship with the customer, and the word of mouth that gets around the reputation of the organisation. So, as I said, the objective of CRM is to manage that relationship, ultimately to get new customers, keep your good customers around, and perhaps drop the bad customers. Now, in a standard kind of corporate or capitalist economy, that makes a lot of sense. It's entirely rational to encourage poor customers to leave the organisation. Capitalist organisations are about maximising profit. The reason I've got ethics with a question mark there, is that some organisations provide things like essential services. So if you think of, say, a bank encouraging poor customers to leave, you can't engage in society and not have a bank account. So there's a balance there between ensuring that you're providing an essential service with a sector like banking versus ensuring the profitability of organisations that operate in that industry. And there's, for a long time, been vigorous debate about the role of banks in societies and their relationship with customers like senior citizens, students, young people, people who aren't particularly profitable for the bank, and yet need bank accounts. So if all banks try to encourage their low profit customers to leave, where do you go to do your banking if you're not a high profit customer? So there are ethical consequences to this kind of stuff. But really that dot point there is just there to make me feel a little bit better about the lecture. So we'll move on. So CRM is about understanding customer behaviour, customer backgrounds, customer characteristics, so that we can better deliver services and products to customers, to understand what they need, what they want, and tailor our services to those requirements. And of course, to be able to catch problems and opportunities as soon as they arrive. Now, CRM literature has this concept called closed loop CRM. And it's based on the idea that there's three different types of CRM applications or CRM strategies in organisations. Probably the most common kind of CRM activities that organisations engage in are known as operational CRM, and the kinds of information technologies that specialise in CRM tend to focus on the requirements at the operational level. This has to do really with customer support staff, help desk staff, even salespeople on the ground or on the shop floor. Being able to have customer information at their fingertips to be able to make more informed decisions about how to help customers on a day-to-day basis. So you find a lot of CRM software is about managing call centres, managing telephone calls, being able to quickly pull up an individual customer record so that a telephone operator can know the name and date of birth and sort of general background and purchasing history perhaps of the people that they're speaking to on the phone. So operational CRM is kind of the day-to-day coalface type of CRM. Collaborative CRM is something that's a lot less common, but it's based on the idea of, I guess, engaging in a conversation or a reciprocal relationship with customers. That is, customers can get together to help each other. So you see this quite often on support forums on the web. If you buy a particular product and maybe you're having a problem with it, instead of going just to the corporation for tech support, you jump on the web, you find these discussion forums, you find other customers who've had the same problem and solved it, or tips and recommendations for a particular product to buy versus another product to buy. And whilst that often happens naturally, an organisation that's engaged with its user base, engaged with its user community, will often participate in those forums as well. In fact, they may even host those forums. So collaborative CRM is about engaging in a conversation with customers beyond just kind of the day-to-day help desk stuff, but to actually fostering a community and a collaborative effort between the organisation and customers. It's a lot less common than operational CRM, but it's still an important part of an effective CRM strategy, at least a consideration of it in many industries. The one that's most relevant to us, though, is this idea of analytical CRM. And this is where customer data is used to make more strategic and tactical decisions. It's customer data fed to managers who are making decisions about products and services and how to manage the customer relationship. So that's the kind of business intelligence applied to customer relationships. Now, the data for analytical CRM comes from source systems like call centre telephony systems, web-based collaborative CRM and so on. So customer data feeds into analytical CRM, and that's then used to better understand the customers. Now, the reason why this is sometimes referred to as closed-loop CRM is the backflow of data or information from analytical CRM back to the staff running the operational and collaborative CRM, so that better understanding of the customer base flows back to the sort of staff at the coalface of the organisation, so that they better understand the customers too. So it's not just about meeting managerial decision-making needs and supporting strategic and tactical planning and so on, but also it should hopefully affect and change the day-to-day operations of how CRM is handled in the organisation. So you get this closed loop So better understanding of customer knowledge provides better operational and collaborative CRM. That brings in more customer data, and it becomes an ongoing dynamic cycle. Does that kind of make sense? Okay. So what we're talking about in terms of data warehousing and data modelling is really this stuff. And you can see a kind of ETL process going on there. Data being extracted from these other systems, being fed into analytical CRM. So a data warehousing and BI stack is very much what this kind of box is all about from a technology perspective. So it's very similar to classic BI issues. So to understand customer relationships, it's probably a good idea to understand customers a little bit better, and that can be quite tricky in, this is a phrase I absolutely hate. So please, when you do assignment 2, don't start your assignments with this phrase, because a lot of students do. In today's fast-paced, ever-changing business environment, business is tricky, and you know, it's a corny phrase, it's a hackneyed phrase that, as I said, poor student essays seem to start with. There is a grain of truth to it. We are living in an environment in which it's much easier to conduct business in a global, multinational sense. The use of the internet to reach customers that you couldn't have reached possibly 10, 15 years ago means that understanding your customers is a whole lot harder. If I wanted to set up a business and market to China, for example, I'd be in a really tricky spot because I don't really understand the Chinese customer. I have come from a different cultural background, different cultural perceptions, and likewise, Chinese companies trying to market here to Australia have those same kinds of issues. And that's true of whether marketing to India or even the UK or Europe. There's cultural issues to do with understanding people and their actions and predicting their behaviours that are harder to do now, and a lot of businesses are more exposed to now than they used to be. We're also now competing not just with the business down the street, but the business on the other side of the world. So there is this real increase in the need to better understand customers and understand customers in an environment where you're not necessarily meeting face-to-face anymore. It's not like you're running a grocery store and you see the same person come in every week. You're seeing lots of different people that you never meet seeing is the wrong word, coming across customers that you never meet face-to-face. And that creates a challenge for understanding your customers, managing the customer relationship. So there's a role there for technology to play to capture more information, to help inform business owners and business managers more about the customers that they're trying to engage with and the kinds of products that they might require. Okay, all of that being said, there is a general kind of understanding of what a customer is in terms of what's known as the customer life cycle. So the ideal is that you win a customer who's going to be highly profitable for you, and they're going to stay with you and buy your product on an ongoing basis. So you buy one product of a particular brand, and if you like the experience, you're perhaps more likely to purchase other products of that brand as well. So marketers talk about this customer life cycle model. This is really marketing 101, very, very basic sort of stuff. I've taken this from Berry and Linoff, a book on CRM from about 10 years ago. But the model itself is generically the same. So the idea is that you start out with a population base, and you've got people who are potential customers, what's known as a target market. So marketers who are trying to reach that target market will try to understand it. They'll refer to individuals within that target market as prospects or prospective customers. And the aim is to acquire them through a marketing campaign. And a marketing campaign could be anything from classic print or TV advertisements, some other kind of marketing campaign that is perhaps event-based, or maybe it's something fairly subtle, a kind of grassroots marketing campaign, a kind of word-of-mouth kind of thing. But regardless of the style of marketing campaign that's put together, there's a target market that campaign is trying to reach. In other words, an audience. And the intent of the message is to try to convince that audience to respond to the message, become responders, and hopefully purchase a product and become a first-time customer. So as we move along from left to right with this arrow, we kind of end up with a smaller and smaller group of people. Potential target market, message gets sent out, it's crafted and sent out. A certain percentage of those will perhaps respond, perhaps asking for more information or coming into a store to look at a product. And hopefully, crossing this line and becoming an actual customer purchasing a product or a service. So there's kind of a major, at the top level, we've got this idea of acquisition, turning a prospect into a responder, and turning them into a customer, and then trying to retain that customer, hopefully creating an experience where, for the customer, where the product or the service was useful or met the customer's needs well, the relationship is a strong one with the customer, and hopefully turning that customer into what's known as a high-value customer. High-value customer, obviously, is a customer who's highly profitable. Of course, there are other kinds of customers as well. There's the low-value customers, and they're always going to be low-value customers. And you might want to encourage those people to go to perhaps your competitor. But there's also those low-value customers who you think might become high-value customers. And the idea is you want to be able to take those low-value customers and turn them into high-value customers. So a classic example, banks spend a lot of effort marketing to undergraduate students and young people, creating special accounts with low fees and things like that, based on the assumption that once that relationship is formed, as a young person, a student, you're more likely to bank with them once you become a high-earning individual in a well-paid job, and then you become a high-value customer. However, on the other hand, if you're perhaps at the other end of the life spectrum, fairly old, maybe on an aged pension or something like that, the chances of you becoming a high-value customer if you're currently a low-value customer are quite low. Coming back to that ethical issue. Anyway, the idea is that if you've got a low-value customer who's always going to be low-value, you encourage them to what's known as churn. Churn is when a customer goes from one business to a competitor's business. It's the classic industry where this happens a lot is mobile phone companies. So you might switch from Optus to Telstra because there's a slightly better deal, or there's better reception. So that idea of a customer going to a competitor is churn. Generally, you want to prevent churn. So in the telecommunications industry, I've heard all sorts of astronomical figures in the order of, say, hundreds of millions or $1 billion a year that costs the industry because of churn. How accurate that is, I'm not entirely sure. But sometimes churn is a good thing. It encourages customers, some customers that you don't want, to move on. The high-value customer, though, you want to encourage to stick around. And they may leave the organisation because a competitor offers a particular deal or wins them over with a particularly attractive marketing campaign. And one of the things that the organisation would like to do there is win those customers back. Now, at every step of the process, there's that wind tunnel thing again. It happens, I reckon, 10:30 every time. Anyway, we'll power through it. So every step of that process, the organisation can use information to better improve how it handles the activities in that area. So as the target market is being identified, the marketing message is being crafted, information like campaign histories, purchasing demographics, purchased demographics from third-party customer data retailers. Information about that target market allows the marketers to better craft the marketing message. And hopefully that will improve the message so that the response rate increases. And I said earlier, response rates to advertisements are astronomically low. We're talking in the order of fractions of a percent. So if you can actually bump up the response rate by a fraction of a percent of the overall population, you're actually massively improving the marketing campaign. Thanks, Phillips. So at the point that a person becomes a responder, you want to ensure that you've got information about the products and services at hand, the staff are trained and things like that. When someone becomes a customer, though, and then you're trying to categorise them according to high, low, or high potential high, you want to capture customer information about their usage history, their payment history, do they pay their bills on time, what are their responses to campaigns and things like that. What's the likelihood that someone's going to stick around or not churn if you offer them, I don't know, say you're an airline and you offer them a free upgrade or something like that. Those kinds of things help with the day-to-day kinds of decisions with the customer. Finally, once a customer leaves the organisation, then it's useful to know why they left. So finding that out can be quite tricky, but there may be clues in the data from these kinds of phases. So crafting the message to try and win back high-value former customers who've churned is similar to this activity here, but you want to be informed about the history of the customers with your organisation. Why did they leave? What can we do to convince them to come back? So at every step of the process, analytical CRM has a potential role to play to help make more informed decisions. And there's loads and loads and loads of data that can be sourced from lots of different systems throughout the organisation, lots of different sources of information that need to be brought together and integrated. And that sounds like a job for data warehousing and BI. Okay. So in understanding customers, there's a few common terms which you'll come across in the literature and you need to be familiar with. The first is the idea of customer segmentation, trying to group customers together rather than just treating them as an amorphous mass that you market to, trying to identify segments of the customer population based typically on demographic data, but it might be based on history, purchasing history and things like that, so that you can better tailor a marketing message to each of those segments. The ultimate utopian vision of this kind of effort is to come up with what used to be referred to as one-to-one marketing. And it used to be thought that maybe email might be the tool that could be used to craft individual messages. This idea of one-to-one marketing is you tailor an individual message for each individual potential customer to meet their individual needs. So instead of treating the customer base as a mass, you talk to each individual customer and therefore have a better chance of improving the response rate. Now, of course, as I said, that's a utopian vision. It's never really been achieved, at least not on a mass, large scale. But by breaking the customer groups down into their similar sets of needs and requirements, it's better to you're better able to make a pitch to each of those different customer segments. So being able to do that requires lots of detailed information about people's backgrounds, their age, their income levels, their education levels, a whole range of things. This is the reason why particularly retailers often get us to fill out forms with information about where we live, how much we earn, who we're married to, those kinds of things. So, warranty registration cards, for example. A whole lot of information there that just there's nothing to do with the warranty. It's about trying to put you into a group of people who are similar to you so that you can be better marketed to. So that's one way of grouping customers is based on demographic information. Another way of grouping people together so that they've got a sort of more homogenous set of requirements, product requirements and so on, is to analyse purchasing patterns, to look at what people have purchased in the past, so you can make hopefully more accurate predictions about what people are going to purchase in the future. So by looking at a particular customer and their purchasing history, you can build up a purchase profile or a product usage profile of that customer and compare that to other customers' profiles to see what they purchased down the track, so that you can make some predictions about what that individual customer is going to be doing in the near future, or whether they're going to be amenable to a particular marketing message. So by analysing those purchasing patterns and making predictions, you can then send out marketing material based on those predictions that will hopefully have a high response rate. The other thing, and this is perhaps quite closely related, is the idea of market basket analysis. That is, analysing the things that people buy together. And there's this classic tale, or it's only partly apocryphal, but this story that seems every single data warehousing vendor that's ever been around has used to try and sell data warehouses. And they all claim that it's their story, but it can't be because they all use it. We actually found out who originated the story. I'll let you know later. But the story goes that a large supermarket chain, and it's variously in the US or the UK, turns out it was actually the UK, was trying to better understand purchasing patterns in their stores so that they could make better decisions about the store layout. So how to lay the aisles out, what kind of end-of-aisle displays to have, what products to place close to each other. So they decided to do this market basket analysis and analyse what products were being purchased at different times of the day, different times of the week, and so on. It's actually a story that's used not just to sell data warehousing, but to sell data mining. So it was kind of the first data mining success story. And the idea was that this, or the story goes, that this supermarket chain bought some data mining software and analysed the purchasing patterns of their customers to try to discover nuggets of customer information about what products tended to get brought together. And the two products that popped out as one of the findings of this data mining tool was beer and nappies. Beer and nappies. For those of you who have an American bed, nappies are diapers. So beer, nappies. And what they found was that there was males who were white-collar workers. Actually, I'm not sure about the white-collar worker, but males coming home from work on a Friday evening buying beer and nappies. So what they were doing was essentially buying supplies for the weekend, I guess. But no one would have predicted that beer and nappies were things that sold together. And it was supposedly through the magic of software that this piece of nugget of knowledge was data mined from the data repository. As I said, it's kind of an apocryphal story. In other words, there's very little evidence for it actually being true, but we found the people who actually did it. And it was a UK-based, very well-known supermarket chain, and they didn't actually use software to do it at all. So it's actually not a data mining, data warehousing story. They manually went through customer data. They got a bunch of statisticians, and they literally crunched the numbers. Literally, no, sorry, they metaphorically crunched the numbers, but they manually did it and came up with this finding. So we know that it's true, but it's not actually a story to sell data warehouses or data mining. But this is kind of the holy grail of doing data mining, doing trying to analyse customer data, is to look for those pieces of information that the organisation didn't know before. So, they put their beer and nappies together and they managed to get throughput through the store, improve that, and increase their sales. Anyway, so market basket analysis can be a useful way for understanding customer purchasing patterns at the time of purchase, so that you can make decisions about how do we encourage customers to make those last-minute impulse purchase decisions. How can we increase the basket as they're leaving? CRM is also often used about trying to predict which prospects will become responders so that you can reduce your marketing costs. Obviously, if you can narrow the number of people that you're trying to communicate with a marketing campaign, on the one hand, it reduces your overheads, and on the other hand, it increases the likelihood of them becoming responders, to responding favourably to that message. And finally, churn modelling at the end of the customer life cycle, trying to predict who's about to leave so that you can perhaps get in before the competitor does to encourage the customer to stick around. So I'm sure we've all had the experience when your mobile phone contract is about to end, you get a phone call from the telephone company offering you a free handset upgrade or something like that to put you back on another 2-year contract or something. So trying to predict who's going to leave so you can stop them leaving, but also trying to understand why customers are leaving. Is there a competitor's product that's particularly compelling? Was there a bad experience that the customer had, or have they simply not been in touch with the organisation for a while and it's possible they're going to change? Okay. Customer optimisation, it's about predicting what value the customer is and predicting their lifetime value, and looking for high lifetime value customers rather than low value customers, and trying to acquire those and retain them and keep them around. So organisations have loyalty programs and those kinds of things, and other marketing messages to encourage high value customers to stick around. But obviously those things can be very costly. The better tailored, better marketed they are, the better aimed they are at the right customer segment, then the more successful they will be. So doing all of those things requires lots of information. The organisation is better placed if managers are informed about backgrounds about the customer, the experiences customers have with the organisation and so on. And this is where analytical CRM really steps in. But the key is to use that data not just to run customer reports, but ultimately to follow through and develop strategies, processes and policies to increase profitability, to better manage that relationship with customers. And really that's the ultimate aim of any BI tool. It's not to gather data, bring it all into one spot. It's about improving decision making in the organisation. If there's not that follow through from the design and features of a business intelligence system, data warehouse and delivery system, that flows through to some kind of changed practice in the organisation, then we're wasting our time. So very often data warehousing projects in particular, because you're kind of one step removed from the end user, it becomes very tempting to get focused on the data management issues. So data warehousing all of a sudden becomes about improving data quality, integrating data. All of that doesn't matter if you're not actually making any change to the organisation in terms of improved decision making. That kind of touches on the concept of success, and Felix is going to be doing some work over the next couple of years on that kind of idea. Successful data warehousing and BI projects, the actual definition of success can be quite different, or is quite different for BI compared to more traditional kinds of systems. And that's true of CRM as well. But really the ultimate measure of whether we're achieving what we are hopefully achieving is that there's changed, improved decision-making practices in the organisation, and that's flowing through to not just better strategies but better day-to-day operations as well. Now, the tricky thing with CRM data, or CRM and data, is that organisations have masses and masses and masses of data that they're collecting. Organisations jumped on the idea of transaction processing using IT to capture data from what are known as customer touch points, those points in the organisation where customers interact with the organisation, and capturing transactional data. So organisations have got more data about customers today than they've ever had before. You know, terabytes and terabytes worth of data, petabytes of data. The other side of that coin, though, is that whilst they've got mountains and mountains of data, it makes it a lot harder to actually understand the customers. So there's this sort of, the more data we collect, the less we actually know about the customers, because the data is there's so much data, it's so complex, we're dealing with larger, broader customer bases, because we're operating very often in an international marketplace, that ability to have a one-on-one relationship between a real-life person in the organisation and the real-life customer becomes much harder. So with so much data and the nature of the sort of business environment, complexity becomes a real issue, and this is where BI and data warehousing can help, hopefully, anyway. But of course, this data is not transactional data necessarily. What we're focusing on is not the transactional events with CRM, we're focusing on the customer themselves. And that's a different focus that generates different design requirements for the BI and data warehousing stack. Okay, so that brings us to the design issues, designing data warehouses for customer data. It's a bit early to take a break, but it's kind of the logical point in the lecture to take the break. What do you guys want to do? Shall we push on? Or do you want to go grab a coffee? Push on? All right, let's push on. So, over the last couple of weeks, we've looked at dimensional modelling as an alternative approach to the design of the data structure for data warehouses, based on the idea that data warehouses have different usage requirements, different design requirements to classical transaction processing systems and their databases. With OLTP systems, we normalise the data, we structure the data to protect against insert, update and delete anomalies. The data is optimised for very quick, small transactions on the database, typically to put data in or edit that data. The data is not optimised for extracting that data out, for obvious reasons with a transaction processing system. With a data warehouse, though, we've got this subject-oriented, integrated, non-volatile, time-variant sort of definition that we're trying to work with. We want data to come in from lots of different sources. The database transactions tend to be read rather than write. The data that we're parsing with each SQL query tends to be very large amounts of data. So instead of small atomic transactions that you get with an OLTP system, sometimes we're scanning an entire table to be able to calculate just one value. For example, all of the sales for in a particular region. And that could be gigabytes worth of data that's being scanned with one database transaction. So very different design requirements generally for a data warehouse. So we introduced dimensional modelling as an approach to structure data in a way that's optimised for selecting and reading, but also optimised in a way that's user-friendly, because the data structure tends to come through into the user interface a lot more with a BI system than you get with a data entry system. Customer data warehouses offer yet another design challenge. And one of the things that you need to get used to as a data warehouse developer, or a BI developer for that matter, is that you can't get wedded, you can't be ideological about the design approach you take. If you have to sacrifice some of the engineering purity behind a star schema to make the warehouse work in a responsive manner to satisfy a particular design requirement, you do it. Because the ultimate aim is to improve decision making. And with customer data, the focus is not on the fact table that you would classically have with a typical data warehouse. The focus is on what would typically be a dimension within a star schema, that is the customer dimension. So when you're analysing not so much the fact table, but analysing a dimension table, that again shifts the design requirements. So what we're going to talk about in this part of the lecture is a design approach, really a design pattern for trying to analyse a large dimensional table, in other words, the customer dimension. And there's a couple of issues. First of all, there's some data modelling issues, and we'll focus on those first. That's really the bulk of what we'll be focusing on. There's also the design issue of the slowly changing dimension that we talked about last week. So remember, there were 3 different approaches to handling slowly changing dimensions. The classic dimension that changes is the customer dimension. They change address, they change income levels, they change jobs, the demographics change, the activities change, their characteristics change. So the classic changing dimension is the customer dimension. And there's challenges therefore for identifying change data and capturing those changes and following them through into the warehouse. So we'll have a look at that a little bit. There's integration issues coming from multiple source systems. That's kind of classically the same as a data warehouse. But the kinds of integration issues that you come across with customer data tend to be dealing with what's known as deduping or deduplication of data, identifying customer records in different systems and working out whether 2 records with the same name are in fact the same customer, or maybe they're 2 separate customers, or 2 people with different, or 2 records with different names at the same address, maybe they are the same customer. So trying to work out which customers are which from multiple source systems to build up a customer profile from multiple source systems poses some, I guess, an extra degree of difficulty for these kinds of issues that are also dealt with in the classic database data warehouse environment. We're also often dealing with unstructured data. When we're dealing with customer relationships, a lot of the information might be, for example, attitudes of the customer towards the organisation. Maybe some market research has been done, you go and interview the customer, they fill out a survey and write some text. Or maybe they've posted a complaint to an online discussion forum, these kinds of things. Being able to mine that data, to analyse that data, becomes quite tricky because it's not structured. Transaction processing systems have nice relational databases typically attached to them. That means structure gets added to that data as it gets captured. But often, a lot of the data that we're dealing with customers is unstructured information, which makes it difficult to analyse. So there's products that specialise in things like, for example, text mining to analyse that kind of data. There's also real issues around privacy as well. So privacy legislation came in here in Australia about 10 years ago. Just trying to remember the exact date, but it was around about, it was either very early in the 2000s or late in the 1990s, that dealt with this rising issue of organisations sharing data. Particularly when you've got, say, a multinational organisation where, from a legal perspective, you've got an organisation operating in one country and they've got a parent company and they start sharing data together. It starts crossing international or state borders. Yep.
Example of a software that can make text data mining?
I can't remember the names of them, but there are products out there that specialise in text mining. And basically what they do is you feed them text documents and they look for patterns of expression. So there might be predefined patterns that you're looking for, say negative terms or positive terms. They might try to analyse the text in terms of whether it's overall, positive, negative, aggressive, passive.
SPSS.
SPS, but yeah.
SPSS, the typical software for marketing. The typical software for marketing.
Yeah, so that's got a text analysis aspect to it. Yeah. Yeah, yeah.
Where the keyword.
Yeah, it looks for patterns of expression as well. So if someone often uses a particular phrase, and that phrase is tagged as, say, a positive emotion or a negative emotion, then that can flag the customer as either being someone who's really happy or an advocate or someone who's got a complaint. You can look for correlations between those kinds of emotive terms and product names or product codes and things like that.
The question is that kind of like ETL that with embedded is kind of...
It's not really an ETL thing. The text mining, very often with data mining in general, so text mining is a subset of data mining. So it's the use of algorithms to analyze data automatically. Typically data mining happens sort of one step to the right of the data warehouse itself. So data gets loaded into the data warehouse in a structure that's typically designed for the classic kind of BI reporting, the pivot tables, the OLAP style reports, the slice and dice kind of stuff. But very often the data mining algorithms, the text mining algorithms require data in a very specific data structure. So you might take an extract from the data warehouse and load it into a tool like SPSS or other data mining tools, and then run the algorithms over it. So the ETL process tends to be almost a manual process for the data mining tools. So you've automated the ETL process for the data warehouse, but then you create a customized extract for the data mining tool or the text mining tool. But really, text mining tools, they run on blocks of text, so there's less requirement really to structure the text, just other than to make sure that you're handling, I don't know, things like international characters and that kind of thing. But you need the structure in the way that the tool expects it much more than you get with a data warehouse. So it requires a customized thing. So it's separate from the ETL process, and almost separate from the data warehousing process too. Yeah.
So it's like I can store an entire text, and then that will be like my record. And then
Yeah. Well, different tools will expect it in different ways. So it might be separate text-based documents. It might have to be plain text, for example. Or maybe you've got Word documents, and maybe the tool knows how to read a Word document and work through it. Other tools might expect it just in a database, so you chuck text into large text fields in the database, and it uses that. Yeah, it's
downloadable is SPSS. SPSS is downloadable.
no. It's a very expensive approach. However,
21-day trial.
yeah, and there are some units here at Monash that teach SPSS, so.
Well, how
3 weeks.
21 days.
Yeah, specific project. Yeah. But yeah, it's what is it, the Rolls-Royce of statistical analysis tools. Yeah. So if you're a marketer, if you're working with stats at all, if you're a quantitative analyst in an organisation, you'll use SPSS. That's the yeah. SAS is another tool. Yeah, SAS has got data mining in it. Yeah? Okay.
That had like an 18-month.
SPSS now is owned by
Yeah. Was it? It wouldn't have had the text mining stuff in it, though, would it?
Probably no, just me, but I don't know if it does now.
Yeah. Yeah. But anyway, hunt around, and you may be able to. No, I won't say. Just hunt around.
I think a basic edition comes with for about $140 from the shop.
Okay.
With a textbook.
Yep. Yeah. So any stats package that's kind of the stuff that they're aimed at data mining, and a lot of them have the sort of text mining add-ons. So SAS, SPSS. Yeah. Has anyone used R? Does it happen?
It's not.
No, I don't like it myself. Yeah. Sorry, using my Anglo pronunciation of the letter. Yeah. Okay. Anyway, so CRM design issues, particularly the sort of data mining, text mining side of things, the nature of the tools is such that you very often have to do a parallel kind of ETL process extraction, a separate kind of analysis. They're not really well integrated with the data warehousing kinds of tools. Microsoft might have, in SQL Server, they've certainly got data mining tools built into SQL Server. I'm not sure whether they've got text mining tools though, as well. But you might find something there that you can play around with. Okay, so the customer dimension from a dimensional modelling perspective is kind of where all of this data that we want to analyse sits. But in shifting the focus from the fact table to a dimension table, it creates these extra design requirements. And part of the complexity for analysing this data in the customer dimension is that it's really big, and big in two different ways. It's both deep and wide, so depth and breadth is quite significant. An organisation might have millions or perhaps even billions of records about customers. So the number of rows in the customer dimension can be really long, so really deep. Also, you might be capturing lots of information about customers. So the attributes you've got regarding a customer can be quite significantly large. You might have hundreds of attributes. So you've got this one big table that's got hundreds of columns, millions, possibly billions of rows that you're trying to handle. And that essentially is just one big flat file. And trying to use a relational database to analyse a flat file, it's a little bit less than efficient. So we can try and structure that data a little bit differently so it becomes more amenable to a customer-focused style of analysis rather than a fact table style of analysis. And there's a couple of different approaches that we're going to look at today. The first key one is appeared in a book by a guy called Todman about 10 years ago now, so 2001. And Todman came up with what I referred to a little while ago as a design pattern. Does everyone know what I mean by a design pattern? It's very big in the sort of object-oriented modelling community, UML modelling community, the idea of design patterns. It's the idea that you've got sort of pre-designed models that you use and customise for a particular project. So someone's drawn an accounting model, and you take that and base your system on that accounting model. Yeah. So the idea is that you don't have to reinvent the wheel each time. You kind of can distill industry best practice. So Todman in his book came up with a kind of design pattern for structuring the customer data in an analytical kind of way. And it's based on the idea that customer data, or the aspects of customers that you're interested in, fall into two broad categories. There's the customer's behaviour, what they do, the actions that they take, and customer characteristics, their demographics, the attributes that adhere to the customer themselves. So there's the things that they do, and there's information about what the customer is like. And whilst there's a certain overlap, there's broadly speaking, those two generic categories of things. So the customer dimension table in a classic dimensional model will typically contain data about customer circumstances, so characteristics about the customer, where they live, how much they earn, what their age is, the kind of classically demographic information tends to sit in the customer dimension, whereas the behavioural data in a classic dimensional model tends to sit in the fact table. So the purchasing history, the things the customer has done, the responses to marketing campaigns, things like that, will typically sit in the fact table. So that's the classic dimensional modelling approach. And Todman argues, well, look, that's all well and good from a star schema kind of approach, but if you're shifting the focus from analysing the fact table to analysing the customer dimension, then we need to perhaps break that customer dimension up a little bit more and more explicitly address the different kinds of circumstances, the different kinds of behaviours the customers engage in. So Todman says, look, dimensional modelling is fine for most analytical requirements. ER modelling has its benefits too, particularly with regard to analysing sort of the customer characteristics, the customer circumstances. Star schemas, dimensional models tend to work fairly well for the behavioural aspects, but not so well for these circumstances because of the denormalisation of the dimension table. It becomes quite hard to tease out those circumstance type attributes. So Todman's design pattern really is a hybrid between dimensional modelling and classic third normal form ER modelling. If you like, it's kind of normalising that customer dimension a little bit to make it easier to analyse individual characteristics. So let's have a look at customer behaviour first, because it's similar, very similar to the classic dimensional star schema type modelling. So with any classic star schema, the centre of the dimensional model is the fact table. Facts are typically business events, business processes. So if you think back to Kimball's design process, the first step is to identify the business process or the subject, business subject, but that becomes the fact table. So customer behaviour tends to be captured in the organisation as a series of business events or business transactions. So we can use star schemas to capture that kind of information in a classic kind of way. Cheers. See ya. So this is, you know, an example of some customer behaviour, the purchasing history of a customer, what stores they purchased from, what products they purchased, and then, of course, the time dimension to keep track of all of that. This is another example, so placing orders. Here's one for a flight industry and so on. So these are all examples of different kinds of customer behaviour that need to feed into our model. So we want to capture customer behaviour, but we also want to capture customer circumstances. And this is where the dimensional modelling approach doesn't handle the data so well, because the dimensional modelling approach treats the customer dimension as one single big table. You might do some mini dimensions, but really it's treated as one monolithic table, essentially a flat file about customers. And that makes it difficult to analyse those customer circumstances. So the data that's buried in the customer dimension becomes difficult to tease out because we don't have that relational database structure to aid our analysis. Behavioural stuff we do, so we've got star schemas very nicely carve up the behaviour aspects of the customer by the different dimensions, but that circumstance information, the characteristics of the customer, all hide within that one table. So this is where the dimensional, as I said, the dimensional approach breaks down. So CRM Data Warehouse is customer-centric. It's shifting the focus very often from the fact table to the customer table. And Todman suggests that we use a more classic third normal form type approach to modelling that kind of data. So the customer-centric approach shifts the focus from solely on behaviour to that mixture of behaviour and circumstance. And by breaking customers down, teasing out that data about customer circumstances, we can then do that classic kind of customer segmentation. So analysing customer behaviour with a classic star schema model allows us to do things like market basket analysis quite easily, because market basket analysis is about the actions that the customers have made in terms of ordering and purchasing. But doing that customer segmentation depends upon demographic information that's embedded in the customer dimension. So Todman's suggestion is, as I said, to use a more traditional ER modelling type approach that teases out those kinds of demographic, that kind of demographic data into separate tables to allow us to analyse it more easily. So really Todman's approach is a hybrid approach. It's not dimensional modelling, it's not really classic normalised ER modelling, but it's kind of a middle kind of ground. So as I said, Todman's approach is a design pattern really, and he calls it a general conceptual model. And the idea is that you can take this conceptual model and replace the generic entities that Todman's identified with the kinds of entities that you need for your specific customer data warehouse. And the conceptual model is based on three different kinds of entities. So the first two are what we've just been talking about, changing circumstances and customer behaviour. And the third category of information tends to come as the result, or it's an artefact of the kinds of analysis that you might do on customer data. So it's derived customer data, perhaps from a data mining or text mining set of analyses, or a more traditional kind of OLAP style analysis. But it's data that's not really captured from the source systems, but gets generated as a result of performing analysis on the customer data that you want to keep around over time. So Todman refers to those as customer-derived segments. So typically, you know, you've done some data mining, you've grouped customers together, and you want to record the fact that that customer is a member of a particular customer segment. All right, so we'll have a look at each of these in a second, but here's the generic conceptual model. So at the centre of Todman's model is the customer. which is kind of like the customer dimension. But notice that this is not a star schema. It looks like a star schema, but it's not a star schema. The direction of the relationships is the other way around. Yep. If you like, the customer behaviours, which are easily modelled with a classic star schema type approach, show that this model kind of sits off the side of your star schemas. So the customer behaviours tend to be fact table style tables, and maybe they are real, actual star schemas from your data warehouse. Maybe the data warehouse is more than just a customer data warehouse. So imagine star schemas off to the left there, and the customer dimension, or the customer table, is a dimension of those star schema models. But the other two kinds of information are more classic kinds of third normal form entities. So the various circumstances that relate to a customer and the various derived segments, so the segmentation of the customer base into different groupings and allocating customers to those groupings. Okay, does that kind of make sense? So you can see this is a design pattern, it's a structure that needs to be tailored, of course, to your specific customer table, warehouse. So the way you can use this model is to go through each of these different entities, the 4 different generic entities, and come up with the attributes for the customer first, and then move through these other entities and work out, well, what are the different circumstances that we want to model. So each of these outrigger type tables becomes multiple actual entities in your final schema. Okay, so let's have a look at an example of that, or how it might work. So the first thing is to think about what goes into the customer entity. And this is really the data that doesn't change about customers. You want to put in here the static customer information that you don't think is going to change over time. So it might be gender, although all of these things are potentially subject to change. Gender, title, name, date of birth, maybe, well, who knows. Suddenly found out that I was born a year later than I was. Those kinds of things. But this is the data that you are fairly sure is going to be quite stable over time, and if it changes, you're probably not too worried about simply overwriting that data. So name, date of birth, gender, title, and so on. The data that you think will change goes into the changing circumstances tables. Okay, so customer is that's probably the easiest one to handle. So let's have a look at changing circumstances and what might go into there. So what we want to be able to do is to track the changes to customer demographic information so that we can understand the kind of life cycle of a customer a little bit better. So things like a customer moving from one area to another, so changing their address, moving from one socio-economic location to another, customer getting married, the fact that a customer starts to play tennis or picks up a particular hobby. All of these things can give us clues about the stage of life that a customer is at. Are they young, middle-aged, elderly? What are their interests? How do we use that to better tailor our marketing message and so on? If they start to play tennis, maybe we need to market them tennis rackets or something like that. Or maybe it means that they're also possibly potentially interested in golf. Who knows? So we want to be able to model these changing circumstances over time. So we create a set of entities to replace this generic entity here to capture the information that changes over time, things like marital status and so on. So we end up with a model that kind of looks like this. So changing circumstances becomes, here's a customer table with perhaps some attributes that might be relevant. So we keep track of each of the different things over time that we want to keep track of. It's kind of like Kimball's type 2 approach, but in a separate table rather than within the one dimension table. So each attribute of the customer that we want to keep track of changing over time, their address, their marital status and so on, we create a separate table for that information. So marital status here, we have the status, we've got the customer ID, and we've got the effective from and to date. So we can use this table then to keep track of the marital status of the customer as it changes over time. Likewise, as the customer changes their address, we've got, again, that effective from and to date. Keeps track very nicely of how customers change their address over time. So each of the changing circumstances tables will tend to have an effective from and an effective to date. So depending on how you design the system, you can perhaps get away with just an effective from date, but it's probably more efficient to calculate that effective to date as well. So do you see how this design pattern starts to work? You replace the customer entity with the attributes that you want to keep about the customer that tend to be static, and you replace the changing circumstances entity with the various attributes about the customer that you want to keep track of over time. And we'll end up doing the same thing with customer behaviours and customer segments as well.
What would be the primary key in this case, marital status? Include effective date, from and to, and customer ID?
Yeah. Well, you could use a composite primary key, or probably more likely you'd create a separate primary key for this table. Really, you're going to be most frequently analysing by customer ID, the foreign key, to see how things change over time. But yeah, look, if I was designing this without thinking about any specifics of the technical environment that I was designing in, I'd probably introduce a surrogate key. Yeah. Okay, so let's have a look at, changing circumstances, let's have a look at customer behaviour. So we've done that one, customer behaviours. So these are some examples of different behaviours that customers might engage in. And look, they really do look like the classic fact table of a star schema. So sales, orders, shipments, things that customers do. We might include here responses to marketing campaigns and those kinds of things. And you might have other tables that describe these things as well, further off the model, so more classic star schema type things. So we might want to know for the sale what the product was, the time, the location in which the sale occurred, the kinds of classic star schema kind of dimensional structures may also sit around here as well. So this is where things, sort of star schema modelling and Todman's general conceptual modelling overlap most significantly. Okay. Segmentation. Segmentation is based really on the data that you've collected in those other tables. So better understanding the customers and then grouping customers together into various derived segments. So a customer can belong to more than one customer segment. So it's quite possible a customer can be within various groups. And further off this model would be the actual sort of master table of the different customer segments that you've come up with. So the customer derived segment table is a table that records the membership of a specific customer in the segments that they belong to. Notice the direction of the relationship. So it's not the list of customer segments. It's really the relationship that sits between a many-to-many, it's an entity that sits between a many-to-many relationship. So customer segment can have many customers. Each customer can belong to many segments. So this entity here is the one that resolves that many-to-many relationship. It keeps track of which segments an individual customer is a member of. So segments might be things like, it really depends on the kind of analysis that the organisation is doing with that customer data, but maybe they've done an analysis that run an algorithm over the data that predicts the likelihood that a customer is going to churn. So you might split the customer base up into high, medium or low probability of churn. Maybe you've split them up into high, medium or low lifetime value or estimated lifetime value. The probability of being able to upsell or cross-sell a product to the customer. Maybe you've analysed them for credit risk. So it's about grouping customers together into different kinds of customer groups so you can make better decisions about what to do, perhaps from a marketing perspective or a more generic kind of relationship perspective with those groups of customers. So, as I said, these are derived attributes. They don't come from the source systems. They really come from the results of the analysis that's done on the data in those other kinds of tables. Okay, does all of that make sense? It's not too tricky, but yep.
So in the customer behavior, when you have the customer, then you have orders, sales, and previous two slides. Oh yeah, this one.
Mm-hmm.
So for the sale, that would be similar to like the normal star schema, right? We have time, store.
Yeah, so these behavioural entities are very similar to the fact table entities that we have from a dimensional model.
You have other dimensions around them.
You may do, yeah. You may not. Maybe in your customer data warehouse, if it's a data warehouse just for CRM, you might take an extract from the generic data warehouse. So there might be an extra step of ETL. You've got source system, ETL into the data warehouse, and maybe there's a sort of a diversion ETL process that takes data from the data warehouse to a CRM data warehouse. And maybe you denormalize the fact table so that you include some of the dimension information. And these really are just single entities. Or maybe you do just simply hook up your customer structures to the star schemas. Yeah. But just keep in mind this, I just wanted to say, keep in mind that this is not a star schema, this is not a dimensional model. This is a hybrid kind of approach.
Can you give us an example about the segment dimension in this case?
Yep.
Like the customer ID and the segment ID.
Oh, as in the actual attributes. As I said, it's really an entity that sits in the middle of a many-to-many relationship. So I shouldn't draw this because it's not going to appear on the podcast, but I'll draw it anyway. So yeah, so if this is the customer dimension, and this is the customer derived segment. So we've got that's from Todman's model. Down here, you've got the actual list of derived segments. And it would have a relationship like this. Because really, what we're doing is we're resolving one of these. Okay, so in here, really all you've got is and basically those two things. You might have a date from and a date to as customers move from one segment to another. But really, this is just resolving a many-to-many relationship. It's not doing anything other than to say this customer is in this group of customers. And so long as we understand what the derived segment means, and the derived segment would have segment ID, segment description, maybe segment notes, so that a marketer could look at that and go, okay, well, the name of this segment is potential high-value customers. And here's the list of potential high-value customers sitting in here, so that we can send out a marketing message or something like that to them. Okay.
What about granularity?
Sorry?
Granularity.
Granularity. The granularity of the customer table would be individual customer. Yeah. And you notice that we don't actually have a time dimension. The changing circumstances data is based on the granularity is each change to a circumstance. So as soon as we can capture it, we'll change it. So the effective from date, the effective to date is a timestamp, not a granular chunk of time. Even with the customer behaviour data, unless it's forming part of the overall larger data warehouse, and perhaps this is a good reason for having a completely separate customer data warehouse, is that really you want the individual transactions. So the granularity is as fine as you can get with the behavioural stuff, because we're analysing an individual customer, we want to look at their purchasing history, we need to have those individual transactions. Yeah.
Is it possible to higher granularity, for example, like analyzing the ATM transaction? So rather than
higher is the wrong word. It's a fine versus coarse. So yeah, it's a finer level of granularity than you would have for a typical data warehouse. Yeah. Because it's individual transactions that we're interested in, whereas a classic star schema model, typically we're just summarising transactions maybe into sales per day rather than the individual sale. That being said, a lot of classic star schema based data warehouses have individual transaction as their granularity. Okay, so let's perhaps walk through an example from Todman, rather than make up my own. Todman nicely provides an example. This I've linked in Moodle to the chapter in Todman that goes through the general conceptual model, and I'm pretty sure it includes this example. So you can read in more detail the sort of the worked process of coming up with the model. But this should give you a fairly good overview. So imagine you've got an organisation that's a wine club. And the wine club is kind of one of those mail order things. You sign up and join, maybe they're attached to a particular seller, and you order boxes of wine from them on a regular basis. But they also sell not just wine, but accessories as well. So things like glasses, tableware, carafes and things like that, decanters and so on. And they also do things like organising special events, trips out to the winery, or maybe there's a jazz festival or something on. So the wine company wants to be able to better understand their customers, to work out what kinds of events they participate in, what kinds of purchases they've made over time, to better market to them and better meet the customer kinds of needs. So they've got a number of different systems. There's a customer administration system, a stock control system, order processing, a booking system for the events and things like that. So the scenario is the club's losing market share, people are churning. They want to be able to understand the customers better, to understand why they're churning, win them back. So they want to understand which products are popular and which ones are not so popular, which customers purchase which kinds of products, so better understanding the customer base, their market basket analysis. Predict which customers are likely to churn and which customers are likely to respond to certain kinds of special promotions. So let's work our way through it. Starting off with the changing circumstances. So we've got the customer table in the middle there, generic customer attributes, gender, date of birth, the name and title and so on. And these are the demographic characteristics, the circumstances that we're capturing about customers from the source systems. So we're able to capture perhaps whether they've got children, whether they've got a spouse or not, what their marital status is, their address, their income level, employer information, what profession they work in, and a list of their hobbies and interests. Perhaps all gathered through survey, those tick box surveys that you fill out when people sign up. So that's kind of the first two steps of filling out Todlin's model. Completing the customer entity and completing the changing circumstances. So one table for each specific circumstance that we want to keep track of as it changes over time. Notice we don't have an effective to date with child, which is, we want to kind of avoid those morbid things, but otherwise we've got effective from and effective to for all of these. Okay, any questions about that? Yeah.
Is this some of the table of the table around the customers? Are those the time key are one of the composite key contributing to the primary?
Again, you might introduce a surrogate primary key.
Yeah, because it keeps changing, so that
yeah, customer ID won't be unique. That's right. So you'd either have to introduce a surrogate key or incorporate effective from and effective to as part of the primary key. Yeah. But remember, this is a conceptual model, so we're a little bit fast and loose with the strict requirements of the modelling. Yeah.
This structure is like very easily embeddable into an ERP.
Any ERP system? Yep.
Does it happen?
Yeah. As far as I'm aware, all of the large ERP vendors have got customer data type stuff, but it's not necessarily structured like this. Typically, it's structured in the same way it's captured during the business transaction. And it's kind of true with any kind of BI data too. The ERP vendors have, for a long time, been trying to push into the business intelligence market because they are capturing all of that data in one central location. It's exactly what a data warehouse, it's one of the things that vendors often push from a data warehouse is that you're integrating data from lots of different systems. If you've got an ERP system, well, the fact that you've got that system means that you're capturing it in one system. But the data structure is optimised for transaction processing, not necessarily analytics. So organisations will often extract the data from the enterprise system, restructure it during the ETL process and load it into a warehouse. And same with the customer data. So you may or may not have this kind of structure in the ERP system, but you're probably going to find that customer data is spread over not hundreds, but maybe tens of tables, and that may not be amenable. So very often organisations will create a custom database just for the customer data warehouse. But certainly the data's there, it's just a structural issue.
In this type of the structure, how can you manage the change in one of those dimensions, like the income brand change? How can we solve the change?
Oh, remember, they're not dimensions. These are just standard entities. They're not dimensions. But so if there's a change in income band, we create another row. So same customer ID, but new effective from date and effective to date. And with the new income level as well. So you end up with a new row in the table.
So they do not directly connect up to the income and what type of the income brand. You just duplicate it once there is a change in the brand.
Yeah, sorry, are you suggesting we don't change it on a regular basis, we change it only when there's a change? Is that what you're saying? Or asking, sorry?
Like in the start schema we talked in the previous lectures, yeah, once there is a change in our dimensions, maybe there is a new type of something, we just just add one more item in the dimension table, right?
Yep.
So we get one more type. So in this type of the structure, once there is one new item, we get that back to our customer. So in one of like the income, there might be one income brand. So we just
maybe we split one pre-existing band into two separate bands. Is it something like that, maybe?
Yep.
Yep. Well, that would just be a matter of reprocessing that table. So you go through that table and reallocate people to the new bands. The reason we've got the effective from and effective to date is to keep track of the change of the customer from one thing to the next. So if you're finding that you want to, for example, introduce a new income band, we've got the income amount there that doesn't change over time, so that stays the same. But we're just allocating that to a new income band. So the income bands might have been high, medium, or low, and now you want to split medium into two separate bands. So you just look at the income amount and go, well, which of the new bands does this one belong to, and change income band accordingly. We would modify the effective from and effective to dates in that situation. But if the income amount changed, then yeah, we create a brand new row, new effective from and new effective to date, recalculate the income band. Yeah. Any other questions? So this is just the circumstance tables. Let's move on to the customer behaviour tables. So these dark grey ones, these are the tables we identified earlier. So in this case, we're interested in sales of wine, sales of accessories, and sales of event information, tour information. So 3 different kinds of behaviours we're interested in tracking. And they're the basic kind of attributes we're keeping about each one. So what product was purchased, the amount, and what time. Again, you might have a time dimension off to the side here, but it might just be a timestamp because we are interested in individual transactions, not the aggregate level. Same with accessory sales and same with the tours. And again, we might have a master table of tours off somewhere else as well to keep track of things, but remember, this is a conceptual model. So, any questions about this one? No? Okay, good. And let's have a look at some derived segments. So the owners of the wine club, or the managers, were interested in being able to identify customers who are, or grouping customers into high, medium or low lifetime value, likelihood to respond to a promotion, likelihood to churn. So the derived segments allow us to categorise customers according to those different dimensions. So as allocating a customer to one of those lifetime values, so the value band would hold that high, medium or low, and the projected value would be based on some algorithm that makes a prediction that would happen during the ETL process. This is a purely historical one, so what promotion they responded to, date of the response, and churn events. So maybe they churned away from us, maybe they churned to us, destination if they went away, and what date that occurred. Any questions about this one?
Projected value in lifetime value projection. All these are based on the outcome of an algorithm, which will be part of ETL or it will be a separate one.
Sorry, part of the
ETL or it will be a separate program that will run in data as a job.
Could be either. But I'd imagine if you're allocating all of your customers to one of those projected values, and the first time you do it would be a separate tool, perhaps. But if you're going to keep updating your customer data warehouse, you would incorporate that into the ETL process so that it happens when the data gets loaded over time. But yeah, remember these result from analysis which is done on the data.
How do the company usually define company events? Like how long do they not come in? They define us and leave the company. In most cases, it's policy-based. Sometimes you've got very clear information. For example, if you're a telecommunications company, you know when a customer's contract ends, you know if you're still sending them bills or not. So they sever that relationship. In the case of this wine company, maybe they have a membership that they have to renew. So when their membership is not renewed, then they regard that as having churned. Or maybe they've got a bit of competitive intelligence and worked out that this customer is also a member of this club over here. I'm not sure how they would get that information, but who knows? It happens. So there's all sorts of different ways that they'd find out. And maybe they just have a policy of, if a customer hasn't purchased from us in the last 6 months, we regard them as having churned. Yeah. Of course, when they churn to us, then we know straight away that we can work that out fairly easily. Okay, so that's just a small example, but you can see how that works fairly effectively to come up with a series of data structures that we can then analyse quite easily for various kinds of decision-making requirements. So instead of just having all of this stuff denormalised and crammed into a single customer dimension, we've teased it out into separate data structures to support different kinds of analyses. So Tubman's approach is based on this general conceptual model, and he argues for a distinction between conceptual, logical and physical models, keeping that distinction very, very strong. Because the conceptual model allows you to focus just on the business requirements, and then the physical model at the very end allows you to work out, well, how do we actually implement that? So things like surrogate keys versus incorporating a timestamp into the primary key, they have performance impacts that vary from one DBMS to another, one style of usage to another. So really what Todman's trying to come up with is a structure that is, on the one hand, user-friendly to support OLAP type analyses in a BI tool without having a single, essentially flat file customer dimension, but also allow easy technical implementation. So it's a combination of a hybrid approach of ER and dimensional modelling with his approach. Kimball's a little bit different. Kimball, similar. So when I say a little bit different, I mean literally a little bit different to Todman. Kimball devotes a chapter or two in a couple of his textbooks to dealing with customer data. But Kimball's focus is not so much on an alternative to dimensional modelling. He uses dimensional modelling as the standard kind of process. But to handle that situation of dealing with such a large, complex, broad and wide customer dimension, he advocates a kind of snowflaking approach. So normalising the customer dimension a little bit, which essentially is what Todman's doing anyway, so it's kind of the same thing. But Kimball's material tends to focus a bit more on some of the technical issues around things like change data capture, identifying that customer data has changed so that we can record that, and how you capture those different kinds of things, behaviour versus circumstance. You might have different strategies. But also technical issues to do with how systems that capture customer data integrate with the customer data warehouse. So change data capture is the phrase used generically in the data warehousing industry to refer to identification of values that have changed in the source systems. The ideal utopian approach to running an ETL process is that you would only run the ETL when there's data that's changed in the source systems, and ideally you'd only want to load in
extract data from the source systems that has changed. If the data in the source system hasn't changed, then you'd ideally like to rely on the copy that you've already made from the previous time you ran the ETL process. It turns out that this is a really wickedly hard problem to solve though. Identifying what data's changed and only extracting and loading that changed data into the data warehouse can be a real challenge. The problem comes largely from the fact that often we're simply overwriting data in the source systems. So you need some way of working out what records have changed and when they've changed and when you last ran the ETL process so that you can do a comparison and say, well, these records haven't been touched since last time we ran the ETL, we won't load them. These records have been touched, so we need to extract them and load them into the warehouse. In fact, the problem is so hard that most ETL processes actually do a complete dump. Dump the warehouse and load it afresh again. So load all of the data into the warehouse every time they do the ETL process. Because the overhead of identifying changed data is greater than simply doing a mass delete and load. So it's quite a challenge. But if we're trying to handle slowly changing dimensions, we don't want to do that complete drop. We want to be able to identify that data has in fact changed. We don't want to just delete it from our warehouse and do a complete refresh because we're going to lose all that history. So in structuring, the structure of the star schema allows us to capture that changed behaviour quite easily and store that changed behaviour. So it's not such a challenge from behavioural fact table type data. The real challenge comes from the changing circumstances data. So in the fact table, we've got a time dimension. The fact that events occur in a sequence in the transaction processing system quite easily allows us to identify those changed values. It's the changing circumstances that changed data capture becomes a real problem.
Sorry, I didn't mean to interrupt, but
No such thing.
if the data warehouse is supposed to be time reload.
Yes.
So how can I dump everything and then reload?
It's, as I said, for the fact tables information, you can completely reload fairly easily because the data's recording events. So that history of events is in the source system. So the history of sales is there, for example. So if you've got a sales fact table, you can quite comfortably drop the sales fact table, drop the data in the sales fact table and recreate that based on what's in the source systems. It's the changing circumstances where you don't want to do that and it becomes a real challenge. But some organisations say, look, you know, whilst it'd be nice to keep track of that changing data in the dimensions, it's just too hard to do. There are consulting companies.
Means, from the source system or in the data warehouse? I mean, because in the source system they will simply override the details of changing dimension, like customer was single and now is married. So
yeah, that information they'll overwrite, and that's why it's an issue for the dimensional information. For the behavioural data, it's not such an issue because we're keeping the history of transactions is kept around in the source systems.
So in data warehouse, I have the snapshot. Okay, the customer was single.
Yep.
Now in new month or whatever is the granularity of picking the data.
Yep.
The customer, the details have changed now. He is married.
Yep.
But that detail of being single in previous month is still there in data warehouse. So if I compare it, I'll easily know that there's a change.
The word easily is the wrong word. The problem, yes, that's exactly what you do. You compare the data you've got in the data warehouse to the source system, and if it's different, then you update the data warehouse, create a new record perhaps in the customer table, and that's the identification of the data, of the change. But it's harder to do than it is to say. First of all, you need to map the warehouse record to the source system record, and there may be 15 different source systems, so you've got to try and map that across. Maybe the changes only happen in one of the source systems, not the other source systems. And the overhead that it takes to compare one customer in one system to a customer in another system, maybe you have to scan the entire table. If you've got, maybe you have to scan the entire customer records in the source systems. Say you've got 15 source systems and you've got, say, 10 million customers. You've got 10 million customers in your warehouse that you're comparing against 10 million in 15 different systems. You can see that the overheads start to mount up. And that's why it's such a hard thing to do. So you've got duplication issues, deduplication issues. You've got large table scans, and you've got a batch window to run the ETL process that might be, say, 8 hours long, which means that you don't want your ETL process to be longer than 4 hours in case something goes wrong and you need to restart it. So it's, yeah, that's exactly what you do, but it's not easy. Yeah. There's companies that develop tools purely just to do this change data capture stuff. So they make a lot of money from selling a product to help with this kind of problem. Okay, so it's more difficult to do. Kimball talks about his different, type 1, 2 and 3 approaches to handling changing data, but really the trick is not so much the storage of the change data, it's the identification of the change. And these kind of complex issues to do with synchronization. So maybe the change, like I said before, only happened in one of the 15 source systems. So there's synchronization issues across source systems, synchronization issues with the ETL process. Yeah, it's not easy. And a lot of it is to do with temporal synchronization issues, so time aspects to the data, and duplication of records, so identifying duplicates. So Kimball's approach to handling customer data, he talks about those kinds of synchronization issues as being technical problems that are sort of to the side of the modelling. So really he says the modelling is not the real problem with building a customer data warehouse. You can use a classic star schema type approach, and he walks through that process. But the real challenges are that change data capture stuff. But anyway, as I said earlier, the customer dimension is wide and deep, and that can create a problem from an analysis perspective. So Kimball's approach is to it's kind of similar to Todman's approach, but to break down the customer dimension into sort of mini dimensions. So utilising that mini dimension approach that we looked at last week, or even creating outrigger snowflake tables. So everyone remembers the snowflake diagram that I showed a couple of weeks ago and said, don't snowflake, never snowflake. This is the one situation where it does make sense. Because the focus of the analysis is shifting from the fact table to the customer table. So if you're analysing the customer table frequently, then for the same reason that you create mini dimensions when you're analysing the fact table by certain attributes, you want to have a structure there that supports that analysis. If you're doing analysis on the customer table, you want to have structures around the customer table that support the kind of analysis that you're doing, which is what Todman has done, and really it's essentially the same as what Kimball's done, but he just calls it a mini dimension or an outrigger table. So here's an example of a classic customer dimension with demographic information, and what Kimball would design as a solution with regards to mini dimensions for those demographic groupings. So creating a demographic dimension that is really a mini dimension of the customer, or degenerate dimension of the customer dimension. There should be a foreign key from demographic in the customer, but yeah. So does all of that make sense? So it's mini dimensions. You can actually break down the different kinds of behaviours as well. But it's still a classic star schema approach. You've got a fact table and dimension tables. And this is the snowflaking that you might do. And the reason why this works as a snowflake or outrigger structure is because the analysis is being done on this table, and we're grouping this table by these pieces of information. If the analysis was being done on the fact table, then this outrigger table is actually harder to use, which is why mini dimensions are used with the classic star schema approach. So only getting away with star schema here because the focus is on analysing this table. Okay, customer data. Look, Kimball talks about this stuff as if it's a separate problem to classic data warehousing, and really it's not. These problems apply to normal data warehouses as well as customer data warehouses. The problem with customer data warehouses is that the granularity is a lot finer. So a lot of the tricks that we can get away with to make the granularity a little bit coarser, to reduce the size of the data warehouse and therefore speed up the queries, we can't do with customer data because there's a greater need for that finer level, transaction level granularity. So it's harder to increase the performance of a customer warehouse using the kinds of aggregate tricks and the granularity tricks that we do for classic warehouses. Kimmel also talks about a lot of the data for customer information coming from web-based or online channels or touch points. But that's true of classic data warehouses too. A lot more data these days is coming in via the web. There's two aspects to that. One is usage logs of your website you might want to have analysed and feed into the data warehouse. It becomes another source system that feeds in. But you're also, if you're doing electronic commerce, if you're selling via the web, you want to be able to do analysis of how people move through the site, the responses to particular promotions, advertising on your site and things like that. So data feeding in from the web is now a massive source of data that's often being analysed by a warehouse. So it could be terabytes worth of size. And yeah, like I said, granularity has to be much finer for a customer warehouse. So there's an order of magnitude more data that needs to be stored, and there's fewer things we can do to reduce that size to speed up the queries. So it's a greater technical challenge. Okay, so again, a lot of these issues are the same issues you come across with a classic data warehouse, but ramped up a bit for customer data warehouses. So lots and lots of different sources of data beyond just simple transaction processing systems. You might have a particular marketing manager who created their own Access database for a list of the marketing campaigns or campaign ideas, or maybe you've got a salesperson's notes from interactions that they've had with different customers. So there's a greater range of potential sources of data than you find with a traditional data warehouse. And that data is very often less structured than classic transaction processing systems. So there's a need for more exotic kinds of analysis tools like text mining. The data tends to change quite a bit for customers, partly because we've got that finer level of granularity, so smaller changes produce more changes. There's those privacy issues I mentioned earlier, and you've got the same evolutionary pressures on a customer warehouse as you have for a classic data warehouse as well. So it's really quite hard. It's an extra degree of difficulty with customer data than you get with a classic warehouse. Slightly different design requirements, and therefore leading to possibly a different modelling approach like the Todman kind of approach, or maybe an Outrigger Snowflakes type approach. Okay, so these are the two main references for this material. So Todman's book you can get from the library, but you can download chapter 3. Turns out the publisher decided to make chapter 3, which happens to be the chapter that's relevant to us, the sample chapter that you can download. But I've provided a link on Moodle, but if you want you can type that in manually if you like. Or the Kimball 2002 book has got a chapter on customer warehousing, so chapter 6 from that book. Any questions? No? Okay, in the tutorial we're going to have a crack at doing some Todman, or a Todman model, so you can get a chance to practice the Todman stuff. Otherwise, don't forget the assignment's out, so you can start working on that. Don't forget to post questions to the client via the discussion forum. I'll see you guys next week. Cheers, everyone. That's not us. You can take it if you want. We will have a tutorial later on as not something to talk about, but as a consultation group, so you can sit down and look at the designs and get some feedback. But yeah, you want to get started on it before. Yeah. Well, If you've got questions now, post them to the discussion forum, because chances are other people got the same questions. So.
Nothing will appear. Like you said, for all the delivery systems, BI, does it have to be based on data warehouse or it should be on an ERP itself?
The delivery system tools, in nearly every case, agnostic as to where the data comes from. Obviously, there's an impact on performance. So one of the advantages of AWS is that you can tailor it for the kinds of data access that a BI tool expects. But you can point, as long as it's a relational database, an ODBC connection or an ODB connection. In many cases, flat files are supported, Excel is supported, XML is supported. You don't need a data warehouse. The point of the data warehouse is to solve the data management problems that you have to solve every time you do another BI tool. So an organisation might have lots of different decision support systems and they all face the same data integration, data management issues. So the data warehouse is there to solve that on a single quality, it's easy to access, good quality data.
I was doing one of the projects for enterprise system. So there I was looking at SAP as a vendor. So SAP has its ERP, it has CRM, it has SCM. It also has a BI now.
Yes.
Business object they acquired.
They've always had a BI tool as part of their offering. Has a really bad reputation.
The BI?
Yeah, because their mindset is transaction processing, and it's a very different mindset to design for BI. And they didn't do it. But they acquired business objects, so they got some skills in.
So because they don't have any data warehouse solutions, so I was just wondering whether the BI would be...
Well, they kind of do now. I mean, it's still bundled as part of their overall ERP package, but what's going on inside the package is that they're basically creating an internal data warehouse. So creating tables and things like that. They kind of look like a star schema structure. It's just it's not a separate database.
Yes. Thanks. Thanks.
Yeah, I wanted to make a question, but I think I will do it. Can I do it now? Or? Yeah. Okay. The question is, I'm trying to do the assignment. I'm doing the assignment, sorry. And I mean, there are 3 different databases, and
Yes.
I can click on one. And I was thinking to do a sort of consolidation of 3 tables, 2 or 3 tables, I will see. I mean, this kind of consolidation, when you consolidate data on the basis of like the name of the customer or
Don't forget to grab the handouts. It's about 4, so make sure you grab them all. Yeah, there's a couple more on that table there as well, just in front of you. Yeah. Aaron? Just grab those two as well on the table.